Good afternoon. My name is Jessica Thomas, and I'm a postdoc in the Coburn Lab. And I'm interested in understanding how sense of touch is altered in autism spectrum disorder. Autism spectrum disorder, or ASD, is a neurodevelopmental disorder that is characterized by impaired social communication as well as repetitive behaviors. In addition, individuals have abnormal responses to sensory inputs. The mechanisms that contribute to these sensory deficits are poorly understood. Therefore, I'm interested in understanding the processes that contribute to impaired responses to tactile input. To study this question, I will be using an ASD mouse model in which mice harbor a mutation in CAMK2 alpha that was first identified in an individual with ASD. Since its original identification, CAMK2 alpha E183V has been identified in numerous individuals with ASD as well as intellectual disability. As a consequence, the gene that encodes for CAMK2 alpha has been labeled as a category 3 syndromic risk gene for ASD. The mice that we use are referred to as E183V knock-in mice, and these mice exhibit the core phenotypes of ASD. While I was in the process of beginning to characterize tactile behaviors for our E183V mice, the DSC facility changed the bedding from a coarse cob bedding to a smooth paper bedding. This impacted my ability to reproduce some initial key findings. To overcome this challenge, I bred mice on separate cohorts of cob or paper bedding and characterized these behaviors in parallel. In the interest of time, I will just summarize my findings, and I encourage you to come to my poster for more information. To assess tactile sensitivity, I used the von Frey-Filament test, and I found that tactile sensitivity was decreased for CAMK2 alpha E183V homozygote mice raised on cob and paper bedding compared to wild type, and that this response was exaggerated for mice raised on cob bedding. I also began to characterize whether or not our mice could discriminate between two different textures using different tests. So one test that I used was the texture preference test, and the other test was the sandpaper test. For the texture preference test, mice used their whiskers and paws to explore either a smooth or a rough cube, whereas for the sandpaper test, mice used their paws to explore a smooth or rough side of the floor. And so for the texture preference test, we found that wild-type mice raised on cob bedding spent more time exploring a rough cube opposed to a smooth cube, and that this interest in this rough cube was absent for our homozygote E183V mice. Interestingly, wild-type and homozygote mice raised on paper bedding had no preference for a rough or a smooth cube, which suggests that for mice, homozygote mice raised on cob bedding, texture discrimination is impaired, and that perhaps for wild-type mice raised on paper bedding, that the bedding shapes this behavior. For the sandpaper test, we found that both wild-type and homozygote E183V mice spent more time exploring the rough side of the floor, and that this is also similar for wild-type mice raised on paper bedding. However, this interest in the rough side of the floor was absent for homozygote E183V mice raised on paper bedding, which suggests that these mice also have an impairment in texture discrimination. And since we know that CAMK2 alpha plays a critical role in learning and memory, we're interested in understanding how memory may play a role in the ability of our mice to discriminate different textures. So we performed a modified version of the novel object recognition test in which mice were trained for 2 days with 2 cubes of a similar texture. And on the third day, one of the cubes was replaced by a novel texture object. And so it is expected that if mice remember and are able to discriminate, that they will spend more time with the novel textured cube. And that's exactly what we observed for wild-type mice raised on cob bedding. However, there was no interest in the novel texture cube for the homozygote EV mice raised on cob bedding, suggesting that texture discrimination is impaired. Also, as previously seen before, there was no preference for the wild type or homozygote EV mice raised on paper bedding, suggesting that bedding modulates this behavior for wild types, and perhaps still there is some inhibition of texture discrimination for the homozygous mice. So we take all of this data together, we can say that tactile sensitivity and texture discrimination is impaired for our homozygous E153V knock-in mice, and that this behavior that we're seeing can be modulated by factors such as bedding. And with that, I'd like to thank all the different funding sources that allow for this project to be conducted. Thank you.